All right, so we are on lesson 6, spreads and distributions. So we're going to go through how to calculate the range and the interquartile range. So the range is just one measure of spread where you do the maximum minus the minimum. And then to calculate the quartiles, the first quartile is kind of the median of the first half of the data, and the third quartile is the median of the second half of the data. So what you do is you go 0.25 times n plus 1, or it's going to be the 2.75 data value. So you go to the second data point and you take that and add 0.75 times the difference between the second and the third value. And then the median is going to be zero point 0.5 times the n plus 1, or 0.5 times the 11th data value. In our case, for if you did the pulse rate of 10 students. And then you go 0.5 times the difference between the fifth and the sixth value. Same thing for the third quartile. You go 0.75 times n plus 1 times, and it'd be the 8.25 value. And then what you do is you go to the eighth value and go 0.5 times the difference between the eighth and the ninth value. Interestingly, though, there are different ways to actually calculate the quartiles. So Python at times can do that, and your answer could be a little bit off from how you hand calculate that. So I'm going to show that in a second. So the first thing I did was mount in my Google Drive. And then I'm going to import the data set here. So I'm going to the lesson 6 spreads of distribution data set. Just copying the path. Remember, your path might be a little bit different here. So if you have it in your downloaded folder, just make sure that you know what path it is and then just read it. You can always just print it off by pressing L6 data, or use the head function to just look at the first like 5 or so data values. So now what we're going to do is just do a data frame of the female pulse. And then what I'm going to do is sort these values. So I can sort them really easily using this and use the sort values function. So that lists them from highest to lowest. Then here I can actually calculate the summary statistics to find those, the minimum and so on. So it's really easy to find the minimum and the maximum. We have 62 there and then 75. The middle value is 69.5. So if you look here, we have 1, 2, 3, 4, 5, and then this would be 6. So the median is the average between 69 and 70, which is 69.5. The next thing that we do is we can find our quartiles. So we're finding the difference between the values here, which is 67 and 68. So you take 67 and 0.25 times the difference between 67 and 68. So that's going to be 67.25. Similarly here, you do 0.25 times the difference between 70 here and 71. So you go 70 plus point, I'm sorry, 0.75 times that difference. So 70 plus 0.75 times 1, which gives you 70.75. So then here to find the range, did the max minus the minimum. And then the interquartile range, I just put in the values for Q3 minus Q1 there. So you just go ahead and put all those in. You can do a box plot by hand, but you can also just do a box plot with the Seaborn function. And then we're going to look at another measure, which is the mean absolute deviation. So you find the mean, and then the deviation is a value minus the mean, and then you take the absolute value, and then you find the sum of that. So here I did the blood pressure column, found the mean, so you can kind of fill in that value with all the means. The deviation is the blood pressure column minus the mean. So there are those values. And then what we do is take the absolute value of those, and then we would find the mean of the absolute value, which is the mean absolute deviation. Now there's actually a function for that. You do the MAD of that. So that stands for, it's not MAD, it's mean absolute deviation. And you can calculate that directly. And then here for task 3, you can compare data sets by finding the spread of the data, by finding the differences in the means and the mean absolute deviation. So if you look here, we can do Regina's times and find the mean. And then after that, we can find the mean absolute deviation of those. So I'm just going to go through here and find the deviation. And then also find the absolute value, find the absolute deviation of the mean, and then go through here and find the mean absolute deviation, which is 2.3. And then I can do the same thing for Erica. So I'm going to go through here and just do the mean and then skip to the bottom to the mean absolute deviation. Students would need to calculate that by hand. And then what you would do is just compare the means of the two runners and then the absolute deviations. So if you look, Regina has a slower running time because she's at 30.3 compared to Erica, who's at 29.9. So on average, Erica's a little bit faster. And then you can compare, well, the mean absolute deviation is about 2.3 compared to 1.32. So because this is smaller, this means Erica is actually more consistent at running the same speed. So the next thing that you're going to do is work through these problems here, and I'll let you just find the average scores and variabilities using mean absolute deviations, ranges, and interquartile ranges. And then again, those functions are put into your Python notebook, but I would work on calculating them by hand as well to get that practice in. And then here, looking at this, you're going to calculate the mean of that and then look at the variability in terms of the mean absolute deviation.